right, so looking at my proof, I have given information from the picture. So we have to list out our given information. So for a proof, it's not enough just to see it, we have to write it too. So LM is congruent to LO, that's with one ticker. And then MN is congruent to ON, that is with the two tickers, and that is my given information. Now I can prove that LN is congruent to itself, LN. So I'm going to draw that in the picture, and that would be using the reflexive property. There is a bank at the bottom that you're going to use, right? And then eventually we'll take the bank away. So this information should be enough to prove that my two triangles are congruent. So there's one of these 5 ways that I can prove my triangles are congruent. And if I look at my statements, I talk about a side, and another side. So I need to use 3 sides. So I'll use the side congruence. You do need to include the congruence because there's another thing that uses 3 S's that's slightly different. All right, so looking at our second one here, I have parallel lines. So a small hint, parallel lines will give congruent angles. I just have to find where those congruent angles are. So I'm also given that angle R is congruent to angle S. I can see that they're both 90 degrees, and 90-degree angles have to be congruent, but that's given to us. So I want to know how I can prove angle 1 is congruent to angle 2. So I like to highlight my parallel lines, and then I need a transversal, one transversal that works with both of those angles, and it'll be this diagonal. So here are my parallel lines, and then my diagonal. Anybody know what the relationship between those 2 angles is called? You can use the chat box. These are alternate interior angles, and alternate interior angles are going to be congruent. So parallel lines will always give you congruent angles. I just have to find them and then name what they are. All right, then I have QT is congruent to QT. That will be my reflexive property. And I should have enough. So if I go back, parallel lines aren't going to help me with congruent triangles. But I do have an angle with R and S, another angle with 1 and 2, and then a side with QT. So here's one angle, that second angle and the side. Here's that one angle, the second angle and the side. So 2 angles and 1 side is going to be one of these. So I just have to evaluate where the side is. My side is not between the 2 angles. If it was between the 2 angles, I would look at side QS and I would look at side QT, but I have a different side. So I'm going to use my angle side for that congruence. Okay. Looking at problem number 3, I have some given information. I'm given with one ticker that GI is congruent to IKI, and that HI is congruent to JI with my given information. Now, I should be able to prove that angle GIH, which is here, is congruent to angle KIJ, which is here. So if I look down, they are not alternate interior angles. They're not a reflexive property, but they are vertical angles, and vertical angles are always congruent. Vertical angles come from 2 intersecting lines, and they are angles that are 180-degree rotations of each other. So angle 1 is congruent to angle 2. If I rotate from that vertex, rotate it 180 degrees, it'd be the same. I can also look at these 2 angles that will be congruent. So I will do a proof of vertical angles of why they're congruent later, but we can use that they're going to be congruent. So vertical angles are congruent, so this should be enough to prove that my triangles are congruent. If I look at my stuff, I have a side, and an angle. So with 2 sides and an angle, my angle needs to be specifically between the 2 sides. My angle is specifically between my 2 sides, so I use the side angle side congruence. Okay. And then looking at that fourth one, we have two sets of parallel lines. AC is parallel to BD, so I'll highlight those. And then I have AB is parallel to CD, so I'll do those in blue. All right, so I have some congruent angles. Parallel lines will always give congruent angles. I just have to find them. So if I look at my yellow parallel lines, I can look at a transversal here. And I can see that angle 1 is an alternate interior with angle 4. So 1 and 4 are alternate interior angles. Let me just make sure that also works for 2 and 3. If I look at these parallel lines here and the same transversal, I can see that these are alternate interior angles. So my alternate interior angles have to come from parallel lines, and my transversal 99.9% of the time is going to be a diagonal. All right, so I've got angle and then an angle. So I also have a side. AB is congruent to AD. It's the same side, so I'm going to use my reflexive property. I should have enough to prove that my triangles are congruent. So I have two angles and a side. So with two angles and a side, I'll use one of these. So I've got to evaluate where is the side located. My side is between the two angles. So 1 and 3 has the side between it. 2 and 4 has the side in between it. So I use angle, side, angle. So 2 use angle, angle, side. 2 angles but not the included side. 4 use angle, side, angle. 2 angles and the included side. So 5 ways to prove triangles are congruent. Does that help a little bit? All right, I'm going to stop recording.